Human activities are affecting all our oceans and its inhabitants. It is important that we understand the effect of our activities so we can mitigate, restore, and manage our oceans and their living resources appropriately. Observing how marine life changes in time and space using non-destructive techniques and technology has become essential to understand ecosystems' resilience, monitor and assess conservation strategies such as marine protected areas.
Video techniques are increasingly used for observing underwater macrofauna and habitats. The STAVIRO is a lightweight video lander that is easily operated from a small boat. It is used to observe and assess fishes and benthic habitats. It is made of two waterproof housings connected by an axis. The upper housing contains a camera, and the lower one contains a motor that rotates the camera housing 60 degrees every 30 seconds.
And what are the differences between the STAVIRO and other underwater observation protocols?
The STAVIRO does not attract fish close to the camera because there is no bait. It is intended for a panoramic view around the camera. It is ideal for detecting shy and large species. Small species can be seen at close distance but are not counted. Because there is no bait nor diver and no light, animals behave in a natural way.
Are there several ways for using the STAVIRO?
Yes, the STAVIRO is used for collecting many observations per day at sea. The Mikado is a STAVIRO where recording times are programmed and it's left in place for several days. It is used for studying temporal variations and animal behavior and is appropriate for underwater observatories.
More than 4,500 STAVIRO observations have been collected in coral reef ecosystems and in temperate ecosystems in the Pacific, Indian, and Atlantic Oceans, as well as the Mediterranean Sea. The landers have been used in different depths and in varied conditions of wind, waves, and currents. This has allowed Dominique and her team to refine and evolve their methods into best practice. They have standardized the end-to-end protocol for data collection and management, image analysis, data analysis, and scientific and non-scientific publications of the results.
And what are your main recommendations for using this protocol?
From our experience, the best practices for high-quality video assessment relate to fieldwork, to image analysis, and to data management. Tailor the survey design to the areas you aim to study to ensure good spatial coverage and replicated observations, for example, in marine parks. This also allows the participation of citizen scientists and non-experts. The collected images must be analyzed in a standardized way using best practices to ensure data quality and interoperability. Data management must be paid particular attention as datasets are large and they involve both images, quantitative data, and data products. This should be consistently managed and stored following FAIR principles with a view to share all the data.
How are the derived data used?
Derived data serve to estimate indicators such as biodiversity indices, animal abundance, presence and frequency, and benthic cover used to qualify the ecological health of ecosystems. These indicators document essential biodiversity variables and essential ocean variables, much needed for local management and for reporting biodiversity at national and international levels.
STAVIRO is a powerful observation tool for research and for routine monitoring. It can record the distribution and trend in fishes and habitats over extended areas and at different ecosystems without disturbance. Such observations are indispensable to better understand the impact of anthropogenic and environmental drivers on biodiversity and ecosystem resilience in order to devise effective ways to mitigate these impacts.
We hope that this protocol can be reused and adapted as widely as possible for both research and monitoring in order to provide guidance for the preservation of marine ecosystems.